Hey everybody, it's Mr. Geiselman. Just going to talk a little bit today about Ohm's Law, which is our new ed puzzle. Here we go. So when we talk about Ohm's Law, it's really important that we understand three definitions. The first definition is current. What is current? Well, when we talk about electricity and electrons, current is the rate at which electrons flow in a circuit. So how fast are they actually moving through a circuit? You can think about it like in a river. Current in a river is how fast the water is flowing. So current in a circuit is the exact same thing. When we use it in an equation that we're going to talk about called Ohm's Law, we use the symbol I because C is already taken for some other things. So we use capital I for current. The unit for current is the ampere or just the amp. We abbreviate that with a capital A. And when we actually measure current, we use a tool called an ammeter. It's pretty self-explanatory. You measure amps with an ammeter. So our next definition then is voltage. You've probably heard voltage before. You've seen it on batteries. You've seen it on lots of things. What is voltage? Well, voltage is the force or the push that causes the electrons to flow, creating current. So the higher the voltage, the more those electrons are going to want to move. Not how fast they're going to move, but how much they're going to want to move. When we use it in an equation, we use capital V for voltage. And the unit for that is the volt. So we can have 1.5 volts. This picture here measures up to 500 volts. That's what we're looking at. And that tool here on the right is actually called a voltmeter. So the tool that we use to measure voltage is a voltmeter. Resistance then is the final piece of this. And resistance is the opposition to the flow of electrons or the flow of electricity. So it's how hard it is for an electron to move through a material. Electrons with really high resistance, we often think of as insulators. Objects or materials with really low resistance, meaning they like to let electrons move, are often called conductors. When we put this into the equation, we use this symbol R for resistance. And this one is actually named after the guy who the law is named after, but the unit that we use for resistance is the ohm, and sometimes we use the omega Greek letter for that symbol. Instead of writing out 15 ohms, we write out 15 with the omega symbol, meaning 15 ohms. And you guessed it, the tool that we use to measure ohms is called an ohm meter. So the tool for resistance to determine how hard it is to push electrons through there is called an ohm meter. That leads us to what is Ohm's law? Well, Ohm's law is kind of demonstrated here in this picture, and it's an interesting picture, I know. Resistance is how hard it is for the amps or the current to move through a circuit. So the amps there, the current is what's moving. Voltage is how hard it's going to push that current through. So voltage is how hard the push is. Resistance is how hard it's going to resist that push. And then the current is the thing being pushed. So that leads us to Ohm's law. Ohm's law says that current and voltage are directly proportional to each other. This means the equation can be rearranged to solve for current and resistance. Or voltage is equal to the current in a circuit multiplied by the resistance. If we needed to, we could solve for current or resistance by dividing one of those variables and rearranging the equation to solve for those specific variables. But V equals IR is the big thing that we need to take out of this, is that voltage is equal to current times resistance. So when we look at that, this is a FET on current or on Ohm's law. So here is Ohm's law. As we increase the voltage, you see that the current also increases. As we decrease the voltage, the current also decreases. Now that's with a steady resistance. If we decrease the resistance, current increases. So as voltage and current are directly proportional, as voltage goes up, current goes up. As resistance goes up, current goes down. So current and resistance are inversely related. So if resistance is high, the current will be lower. If resistance is low, then the current will be higher. So that's how that works. Remember that voltage equals current times resistance. The higher your resistance, the lower your current's going to be. The higher your voltage, the higher your current is going to be. So when we look at this, we can try this in a practice problem. Remember, V equals IR. So the current in a handheld video game is 0.5 amps. If the resistance is 12 ohms, what is the voltage produced? What I'd like you to do is write this down, right? Identify the variables, write the equation V equals IR, and then substitute the variables in to solve. When we do that, the current in a resistor is 0.5 amps when connected across a voltage of 120 volts. So hopefully you guys identify the variables as 5 amps and 12 ohms. And you use the equation V equals IR. You substituted in 0.5 amps times 12 ohms. And 12 times 0.5 gives you an answer of 6 volts. So if you have any questions, let Mr. Oleg or I know, and have a fantastic rest of your day.